Hi, it's Mr. Clegg, and we're going to learn about acceleration today. First of all, the definition of acceleration. Acceleration is defined as the change in velocity over time, or the change in speed over time. It's actually the change in velocity because it includes the direction, but we'll get to that later. So change is written like this with a triangle. The triangle is actually the Greek letter delta. So that means delta V over T, that's the change in velocity over time. So another way to write that is that the change in velocity would be the final velocity minus the initial velocity. Final means the value of the velocity at the end of the experiment, and initial means the value of the velocity at the beginning. So the beginning speed, it's the ending speed minus the beginning speed. And so we divide by the time. So that's the definition of velocity. And this is an equation that we're going to use a lot in this unit. So this is a very important one to write down. Let's do an example of this. The car starts at 2 meters per second and reaches a speed of 10 meters per second in 4 seconds. What is its acceleration? So let's write down the times here. So here we have the time 0, 1, 2, 3, and 4 seconds. And we start off at a speed of 2 meters per second, and we reach a speed of 10 meters per second in 4 seconds. So after 4 seconds, we're up to the final speed of 10 meters per second. And during that time, we have to see what's kind of an equal way we could divide this up. So 2, 4, 6, 8, and 10. So each second, it looks like the speed is going up by 2. So we're adding 2 meters per second. And then the next second, we do the same thing. We're adding 2 meters per second. And then the same here. And the same, well, I missed one. Anyway, the same here and the same here. So I'm not going to write them all because it looks pretty messy, but the idea is each second we add 2 meters per second. So I'm going to write that a slightly different way. I'm going to write it like this. We add 2 meters per second of speed every second. So what that really boils down to is that the acceleration is plus 2 meters per second. So we add 2 meters per second every second. So that's 2 meters per second per second. And so we can write that also like this. You know that when we divide by seconds after the whole thing, we really end up with 2. It's like 2 meters per second per second. But a different way to write that would be 2 meters per second squared. I'm actually going to write it like this, meters per second squared. So the units of acceleration are meters per second squared. You can also have other units like miles per hour per second. So you could have miles per hour per second. For example, if your car can accelerate from 0 to 60 miles per hour in 6 seconds, then you'd have an acceleration of 10 miles per hour per second. So you get 10 miles per hour, 20 miles per hour, 30, 40, 50, 60. So you'd have 60 miles per hour in 6 seconds. So anyway, there are different ways to measure acceleration, but the one that we're going to use mostly is this, meters per second squared. Now, I want to point out another way we can figure this out without doing the table. I picked kind of easy numbers so you could see this visually with the table. Okay, but the other way to do this is, maybe I'll change the color here. We can actually use the equation approach. So we have a car starting out, the initial speed is 2 meters per second. And the final speed is 10 meters per second. always have to have units in order for a number to have any kind of meaning. We don't know what the acceleration is, so that's the question mark. And it takes 4 seconds to do all that. So now we have 4 seconds. And we can actually use the equation. So we can say A equals final speed minus the initial speed over time. So we can put all these values in there. So here's the acceleration equals final speed is 10. I'm not going to write the units now just because it'll make it a little bit messy, but I have to remember that those units really do exist. So it's 10 minus the initial speed is 2. And then I have to divide by the time, which is 4. And so I'm going to simplify all that. So I have 10 minus 2 is 8. 4 on the bottom is still 4. So 8 over 4 is 2. So I get my 2 meters per second squared. And so now the good thing is, look, I got the same answer that I got above when I did it with the table. And the cool thing about this is the table was really easy because the numbers I chose were easy. But if the numbers weren't so easy, the second way, the way with the blue here, will always work no matter if the numbers are hard or easy. So this is a better way to do it. But I did it both ways here so you could see how they're connected. You can see that they're really doing the same thing. Okay, thanks.